This problem is number 1 on the physics midterm review. So this is a projectile problem, and it's been a while since you've done projectiles. So let's get going on how to solve it. So what it says, we're looking at your midterm review, is that you have a physics student standing on a platform located 5 meters above the ground. The student throws a stone. It leaves the student's hand with a velocity of 28.28 meters per second, angled at 45 degrees above the horizontal. Air resistance may be neglected. So the first thing it asks you to find is the total time of flight. Then it asks you to find the range and then the impact speed. So there's a couple things you have to do here first. And we always have to set up our table. So x, y would help if it was actually running. And you have to go through and figure out what values you have for each piece. So in the x direction, you're going to have a v initial x. You're also going to have a v final x. You're going to have a time in the x direction and a delta x. Those are all of your possible x values. You could also list acceleration, but acceleration in the x direction is always 0, so you don't need it. In the y direction, you're going to have a v initial in the y, a v final in the y, and then in the y direction in terms of time, there's a couple things that we're going to have. We're going to have a time up and a time down, if you remember that. And then also in the y direction, we can't just have one delta y, because what does that mean? So we're going to have a delta y of the cliff, which is how tall the cliff is. We're going to have a delta y of the cliff to the peak, and we're going to have a delta y of the peak to the ground. And then acceleration is gravity, which for us is -10. Alright, now we also have two things that are just total units combined, and that is v initial and the angle at which it's launched. So now we can start filling some stuff in. We don't know v initial x or v initial y. We don't know v final x or v final y. We don't know time, we don't know delta x. So we know nothing in the x column. In the y column, like we said, we don't know the v initials. We don't know the time up. We don't know the time down. We know that the change in height of the cliff, though, is going to be 5 meters. Now you can make that negative or positive depending on how you solve. I'm just going to make it negative so you can follow it. We don't know the height of the cliff to the peak. We don't know peak to ground. We do know gravity, though. And then we know our total initial is 28, and our angle is 45? Yeah, 45. Okay, now visually what our diagram looks like, we have our cliff over here. That's 5 meters. We have our object here. It's being launched upward. This way, it's going to go up. And then it's going to hit the ground. So we are going to have delta x over here. We're going to have a height here, which is our delta y cliff to peak. And then we have a height here, which is our delta y peak to ground. That's our delta y cliff. All that good stuff. Now the first thing you always want to do when you reach a problem like this is to break up your velocity into its components. So this is all that thing that you guys really do not like, and that is vector resolution. So what we have, our initial velocity total is 28 right here. Our initial angle is 45 degrees right here. So we have two pieces of a vector in this problem. We've got v initial x over here, and then we're going to have v initial y, which is going to go straight up this way. So we have to find each of those pieces. So the trig operation, v initial y is on the other side of the triangle from the angle. So that means that v initial y is v initial times the sine of your angle. So that's going to be 28 sine 45. Alright, and that is going to end up being 19.99 meters per second. Now, v initial y and v initial x for this particular problem both use 45 degrees. And if you have a 45-degree angle, that means that your other angle in your right triangle also has to be 45. So this is a 45, 45, 90, which means v initial x and v initial y have to be the same size. If you didn't recognize that, you could also just solve for v initial x using more trig. Which would be v initial cosine theta. Same deal, 28 times the cosine of 45. And that's going to be 19.99 as well. So for our velocity, that 28 is going to resolve itself into a v initial x of 19.9 meters per second and a v initial y of 19.99 meters per second as well. So that's the first thing we have to do. Now we need to solve. And when we think about it, what actually is happening in this problem is that we have an object and it's going to travel straight up, come to a stop at the peak, and then continue straight down. So if you remember when we solve, you have two different motions. You have time up, and you have time down. So in the time up section, over here, it's got a v initial here, and it's got a velocity at the top in the y direction of 0 because it's the peak. So you know that it's going to travel this particular problem at 19.99 meters per second to start, and then it's going to finish at 0. And that change is going to be caused by gravity. So we can figure out what the time up is using this equation. V final, V initial, plus acceleration times time. So that is going to be 0 is equal to 19.99 plus acceleration, which is gravity, negative 10 times t. When you solve, you bring over the 19.99 to the left side, so you're going to get negative 19.99, and that's going to be equal to negative 10t divided by negative 10. T is going to be 1.99 seconds. That's the time up for this problem. All right, time up, 1.99 seconds. Now that time up tells us a couple things. One, how much time does it take until we reach the peak, which we can then use to figure out how high up the peak is from the cliff, which is going to be the next point of attack. All right, so to find that, we need to use an equation that has delta y. And the best one for this type of problem is v initial times time plus 1/2 at squared. So you have a couple options. Because of symmetry, what happens is at the top of your projectile, you have up and then you have down. All right, and now these two things are exactly the same. They're symmetrical. So whatever happens on this side is happening on this side. So if you want to find delta y, you can use side number 2 to find it, because using side number 2 is going to cancel out your initial velocity, because in that particular instance it's going to be 0. So this is going to go away. So we're left with the free fall equation, which is delta y, and that's 1/2 gt squared. So to find delta y, 1/2 negative 10, and then the time is going to be 1.99. Square that. So 1/2 times negative 10, 1.99. And you get 19.98 meters. And it's going to be negative, which means it's going to go from a height back down. So that's why it is a negative value. So we can go back up to our table and plug some stuff in now. So our time up was 1.99 seconds. Let's change the color. And our delta y cliff to peak was negative 19.98 meters. All right, now from there we know that the delta y is 5, and then the cliff to peak is 19.98. So when you add those two things together, that's going to give you your peak to ground value. So 5 plus 19.98 going to give us negative 24.98 meters. That is our total height above the ground. All right, we can use that total height now to find the total time down. And once we find total time down, we can add that to time up, and we are good to go for the total time of flight, which is part A. Which I know this seems like a lot of steps. So our delta y, use free fall again, 1/2 gt squared. So negative 24.98 is equal to 1/2 negative 10. T squared is what we're looking for. So you bring everything over, you do negative 24.98 divided by negative 5. That's going to give you 4.996. Take the square root of that, and you're going to end up with a time down 2.24 seconds. Right, now that's the time from the peak to the ground. All right, now the question is asking the total time of flight. And total time of flight is going to come from the minute it leaves the cliff to the minute it hits the ground. So that is going to be T total, which for these problems is always Tx. And Tx is going to be time up plus time down. So time up, 1.99, time down, 2.24. You add those together, and you are going to get 4.23 seconds. So that is the total time. And that's the answer to part A. Total time, 4.23 seconds. Put that up here. Right, because that's the answer to time X, as well as part A for the problem, we're good to go. All right, now part B is asking for the range. All right, now range is the delta X value, and there's really only one formula we can ever use in the X direction, and that is because there is no acceleration in the X direction. So the only formula we're left with is the constant velocity one, and that's velocity is equal to delta X divided by T. So we know our velocity is 19.99. We don't know delta X, but we know our time is 4.23 seconds. So you multiply 19.99 times 4.23, and you're going to get a delta X of 84.64 meters. So that's how far away it lands, 84.64 meters away. All right, so once you find the time, everything else seems to really quickly fall into place, and it doesn't take as long as the first part does. So 84.64 goes over here. It's also going to go over here. All right, and then part C is asking for the impact speed. All right, now a couple things with impact speed. If you launch a projectile, it is never going to land straight down unless you throw it straight up. So in this problem, it's launched at an angle, so our projectile is going to hit the ground also at an angle. So that means that we need to figure out not only the x velocity, but the y velocity, and then use that to find the total. All right, now because it is a projectile, in the x direction, we do not experience any acceleration. So v final in the x direction, when it hits the ground, is still going to be 19.99. So we've already found one piece of our impact triangle. So v final in the y direction is the thing that we have to solve for next. Now in projectiles, when we throw an object straight up in the air, what happens is that object comes to a stop, and then it has to speed back up again. So when it speeds back up again, it effectively starts from rest. So what we could do, we've thrown this object from a cliff that's 5 meters high, and it ultimately reaches a point that's 25-ish meters above the ground. If we just dropped an object from 25-ish meters above the ground, it's going to hit the ground with the same y velocity as this projectile. So we can just start it all over from the beginning. So the impact velocity over here, that is a not straight line, sorry guys. V final x is this way, and then we're going to have v final y, which is what we're looking for here, to get our total v final, which is our impact. Alright, so v final x we know. V final y, like we said, we're going to start from rest at the very top of the peak up here. Alright, so this is a velocity of 0. This is what we're looking for down here. And we know that the time down that we found previously is 2.24 seconds. So we can use that information to find v final in the y direction. So we could say that v final is v initial plus acceleration times time. V final, what we're looking for, v initial 0, acceleration gravity, time 2.24 seconds. So we get an impact velocity in the y direction of 22.4 meters per second negative. Makes sense because it's going down. So to find our total v final, our total impact, we need to find the hypotenuse of our triangle. So we need to do the Pythagorean theorem. So we have to do v final total squared, and that's going to be equal to v final x squared plus v final y squared. So v final x, 19.99 squared plus v final y, negative 22.24 squared. And that's equal to v final squared. So to get rid of that square on the v final, you have to take the square root of this whole quantity over here. Alright, so that's going to end up being the square root of 901.36, which when you take that answer, 30.02 meters per second. Now, I did not round in my calculator. I used the full values. So if you did use the rounded values, you're going to get something maybe under 30, close to like 29. So as long as you're in the same range, you're okay. So the final answer for this one is that it has an impact speed of 30 meters per second. So it hits the ground faster than it left the cliff, which makes sense because the cliff has a height. So if you throw something from here and it's going to hit down here, it has more time to speed up when it hits that ground point. It's going to be faster here because it is going to have a speed of 2828 or whatever it had initially at the same level. So if your final level falls below your initial level, your speed is going to be faster. Like I said, our answer for part C, get all the way back up here, is about, which I'm just going to write, about 30 meters per second. All right, depending on how you solved it, could be different. And I'm going to fill out this table for you. 2.24 seconds, v final y, 22.24. All right, and that is the end of number